In this lesson, I'm going to teach you a really useful notation that you can use to take a part of the real number line. The interval notation, as it's usually called, allows us to take a part of the real number line and to exclude the rest of it. The main thing that you need to know to actually use the interval notation is that open circles or round brackets indicate that that point should be excluded, and closed circles or square brackets indicate that that point should be included. I think that this is one of those things that are best explained with an example. So let me go ahead and give you some examples and you can see exactly how this works. So I'd like to explain to you how we can draw these three sets by actually following this convention. Now you can see that these ones have open brackets, so these points are actually excluded. This is a square bracket, so this point is actually going to be included. But let's do them one by one, just to explain everything step by step. So let me start with this first interval here. So reading this interval over here, we see that the numbers we care about are between 1 and 3. The smallest number is always on the left, and the largest number is always on the right. The round bracket on the left indicates that we should not include the number on the left, and the round bracket on the right indicates that we should also exclude the point on the right. We said that round brackets are paired with open circles, so that means we should place two open circles at 1 and 3. And the next thing to say is that the real interval always tells us to take every number between the lowest number and the highest number, so we're going to include every number between here and here. Now, if you think about it, that means that this 1 to 3 is actually a set, and the set includes the number 2, for example, but it excludes the number 0, because the number 0 is not highlighted. After this, we can draw the next set. You can see that 2 is excluded, but 6 is included. That means we draw an open circle at 2, but we actually need to draw a closed circle at 6. And then again, we just fill the space between them. Now for the last example, it's a little bit different. We're saying that we're going to start at 3 and we're going to include it, but then we end at infinity. Infinity is not really a number, but it basically indicates that you start at 3 and then you can have any number that's larger than 3. To make this clear, I like to draw an arrow to indicate that this goes on forever. You don't really need to draw the arrow, but I tend to. Now, if I was to describe each of these sets with a sentence, I'd say that the first one gives us all the numbers between 1 and 3, not including 1 and 3. The second set gives us all the numbers between 2 and 6, not including the number 2. And the third set gives us all the numbers greater than or equal to 3. We can actually write these in another way as well. If you think of picking a number in between these two endpoints, which I can just go ahead and call x, then we can write all of these like this. As you may know, this sign over here is called the less than sign, and it also does not include the number on the left. So we're saying that x can be any number that's bigger than 1 but smaller than 3. The next set tells us that x has to be bigger than 2 but smaller than or at least equal to 6. And the last example tells us that we have to have some number that starts at 3 and goes all the way to infinity. So now that you know how to actually use this notation, let me go ahead and tell you a little bit more about it and to explain exactly how we construct sets from it. The first thing to say is that positive or negative infinity always have to be excluded, no matter what. If the real number line is going to be a set of numbers, then any interval inside the real number set is going to be a subset of the real numbers. If this is the case, then it's always going to be true that the area between A to B must be a set, and because it is a set, that means all of the usual set maths must apply to it. Because real intervals are just subsets of the real numbers, then I want you to understand that this notation is just a shorthand for this longer notation I'm about to introduce you to. I want you to imagine picking some random number, which we're going to call x, anywhere on the real number line. Because x lives on the real number line somewhere, then we have to say that x is an element of the real numbers. But for x to actually be included in our subset over here, it must satisfy a bunch of conditions, and this vertical bar indicates the word such that. So that means you can read this real interval so far as a new set where x is a member of the real numbers such that a bunch of conditions are true. If this is your first time actually seeing this notation, you should definitely watch my previous video on the set builder notation, where you'll get very familiar with it. But we want to say that x has to be a number that's bigger than a, and x also has to be a number that's smaller than or equal to b. So therefore, we can say that the real interval between a and b, excluding a and including b, is the set of real numbers such that a is less than x and x is less than or equal to b. Of course, if this changed into a square bracket, then the only change you need to make is to add an equals sign over here. If the other endpoint was infinity, then technically you don't need the other condition, and you just not include it. And if you didn't want to include b, then you could just go ahead and get rid of the equals sign over here. But the whole idea of introducing this notation is the fact that this notation is too tedious and too long to write every single time. Now there are some people that will actually write the set in a different way, which is a is less than x, which is less than or equal to b. I personally don't like doing this though, because these symbols over here are called comparison operators. I mean, you can see they appear over here as well. So I don't usually like to write sets in this way because it's a little bit confusing whether you're actually talking about a set or whether you're talking about comparing different numbers. But because so many people do it, it is okay if you prefer to write sets this way. But I think it's a good idea to learn this notation as well, because it makes some things much easier. There is also one more different convention that I should tell you about as well. Some authors, rather than using open brackets like this, will prefer to use square brackets. So instead of writing the interval in this way, they would write open bracket a, comma b, close bracket. I'm really just telling you about this notation, so if you see it in the wild, you aren't confused by what it means. But I want you to understand that it's the same as what we've written, and I'll just continue to use these round brackets every time. And now I think you're ready for the golden rule. Because an interval is just a set, that means all of the set math we've learnt so far still applies to these intervals. So for example, we can talk about particular elements being inside or not inside sets. So for example, if we had the set between 2 and 6, including 2 and excluding 6, then we can say that 3 is a member of that set, so we can say 3 is in the interval between 2 and 6. On the other hand, we can say that 7 is not actually in this set, and therefore 7 is not a member of this interval. But aside from this, we can also apply the other operations like the and, the or, and the without. Now this is actually something that's best explained with an example as well. So let me bring out a page and we'll show you how we can do this. Now keep in mind that the Boolean operations are just the set operations we taught in a previous lesson. Those we called and, or, and without. Now in this first problem, I've drawn a real number line, and on it I've drawn 3 different intervals. What we would like to do is we'd like to write this whole set as a single set. In order to actually write 3 different intervals as a single set, we're going to need to use these Boolean operations here. Specifically, we want to use this operation, which we called OR. The whole idea is that if you have a number that's inside the blue area, it's either going to be a member of the first set, or the second set, or the third set. For example, if you pick the number 5, it's not a member of the first set, it's not a member of the second set, but it is a member of the third set. Similarly, if you pick the number -2, it's not a member of the first set, it's not a member of the second set, and it's not a member of the third set. Well, for starters, we should identify each of these intervals. The first interval includes all the numbers between -1 and 1, excluding -1. The second includes every number between 2 and 3, excluding 2 and 3. And the third interval is every number greater than or equal to 4. And therefore, we can just write each of these with the bracket notation that we showed earlier. Now, the next thing I want to do is I want to write this whole thing as a single set. Let me call that set S. Well, as we said, you're a member of the resulting set if you're either a member of the first set, or the second set, or the third set. so we can just go ahead and OR each of these to get the final set. Now, if you're unfamiliar with these symbols over here, you should definitely watch the video on the set operations, where I explain them in much more detail. So therefore, we can say that the set S is the interval from -1 to 1, or from 2 to 3, or from 4 to infinity, with all of these brackets set as they should be set. Okay, well this problem was actually pretty straightforward, because we have a bunch of disjoint sets that don't overlap at all. But I want to give you another problem that's a little bit more complicated. Now for this problem, I've given you this set over here, and I'm telling you that it can be written in a much simpler way. What I'd like you to do is to actually simplify this set and find that simpler way. Anytime you want to tackle a problem like this, it's a really good idea to actually draw the intervals on a number line first. So I've added on a number line, and I want you to see that the first interval just goes from here all the way up to here. And then the second interval goes from the number 2 all the way up to the number 6 inclusive. Okay, now the whole idea is that we only want to keep elements that are members of both this interval and this interval. Remember, this symbol means AND. Well, if you took a number like 0, I want you to see that it is in this first interval over here, but it does not lie inside of the second interval. So therefore 0 would not be included in the final set. If you took a number like 2, I want you to see that it is included in the first set, but it's not included in the second set again. Any number between 2 and 5, however, will be included in both of the sets. For example, 4 is included in the first set and also in the second set. But any number bigger than this 5 over here is not going to be included. For example, 5.5 does not lie in the first set, and it does lie in the second set. But then, for example, the number 8 lies in neither set. And the number 6 is included in the second set, but it's not included in the first set. So the main thing I want you to understand is that the resulting set does not include any of this area, and it doesn't include any of this area. The only numbers you keep are the numbers between 2 and 5. But then what about the endpoints? I want you to see that 2 is not included in the second set, so it's definitely not going to be included in the result. 5 on the other hand is not included on the first set, so it's not going to be included in the result, because it's not a member of both sets. So therefore, as you can see, the set between 3 and 5 and 2 and 6, with the bracket set as shown, is the same thing as this set between 2 and 5 exclusive. So instead of actually writing things like this, you could always replace it for this and it would mean exactly the same thing. Or in other words, these two sets are actually completely equivalent to each other. You can write this with an arrow if you like as well. Now to make this problem a little bit more interesting as well, we could have filled, say, this endpoint here. So instead of this being a round bracket, we'd use a square bracket. Now if you actually did fill up the 5, as we've shown over here, then it's true that the 5 is included in both sets now, and therefore it should also be included in the result. So as you can see, the best way to solve any problem like this, to make sure that you don't get the brackets wrong, is to actually draw it out first and then to actually solve it that way. You could try coming up with a bunch of different rules to actually help you figure out which brackets go where, but I think it's a lot safer to just draw and solve. But that just about completes all the problems I wanted to show you, so let's go ahead and summarize the lesson. In this lesson, we introduced the interval notation for writing out intervals of the real numbers. We said that we could always write real intervals with this notation over here. And we also said that this is just a shorthand for this whole thing on the right hand side. We said that round brackets or open circles exclude particular points. For example, this A is excluded. And then closed circles or square brackets include particular points. So this B is actually included. And the golden rule here is that intervals are sets. And because they are sets, then any set operations we were able to apply to normal sets can still apply to intervals directly. So for example, one of the easiest things you can do with a set is to test whether or not certain things are inside that set. For example, 3 is inside the interval between 2 and 6, but 7 is not in that interval. After this, we also applied a bunch of other Boolean operations to these sets to see that you can actually treat them exactly the same way you would treat a normal set. Constructing real intervals is going to be really important anytime you're trying to solve a problem that's going to be true over a range of real numbers. These intervals are mainly a communication tool, and you'd use them anytime you want to tell somebody about your solution. And I think that just about completes my lesson on the interval notation. Thanks for watching another Trina video. If you want to say thanks, you got to show your friends. Or maybe you should just visit us at trina.org, where you can track your progress and have access to questions and heaps of other awesome stuff. Or maybe you should just like and subscribe. That works too. But either way, I'll see you next time.